So today we're looking at an independent school paper again and a question from a City of London school sample paper. It's quite a difficult question, confused many of my year sixes, and basically every single year I give them this question and you get loads of intrigued and puzzled faces. So you're presented with a circle, triangle and a square and a hexagon. Okay. The question reads, each shape represents a number. Notice how there's no numbers there. And it says, what's the value of the triangle? So most of my students think, okay, well, is there some kind of pattern or something? Is there some kind of relationship between side lengths or something like that? So they think, okay, well, you've got a circle here, it's got one side. You've got a triangle here, it's three sides. And then this, it creates a four-sided shape or something like that. So they think in that way. But then you see the pattern breaks down because you've got a square, four sides, plus a square with four sides equals a hexagon. So that's clearly not the pattern. It's not related to sides. In this kind of situation, it's from the end of the paper. Don't worry too much if you don't get it correct, or because it's intended to be very difficult. In this situation, you need to be quite calm, collected, and just think about what you actually have going on. You have a set of equations. That means that it's likely to be simultaneous. Okay? You've got no numbers though. So we have to look at what pattern presents itself and then try and make an inference. Right? This is what makes this question really difficult. Right? So we've got one circle, which I'm going to call 1C, plus one triangle. I'll call triangle 1T. And then that equals one square. Instead of S, I'm going to go for a Q, just so I don't confuse it with 5, because I'm not very good at distinguishing between S's and 5s. Right? So 1Q. Okay. Now, if we look at the next one, it's 1Q plus 1Q equals 1H, because it's a hexagon. Well, we can gather those terms together and we get 2Q. But the interesting thing is the final one has this statement. So it will be 1C plus 1C plus 1T equals 1H. If we already know that 1C plus 1T is 1Q, we know that 1Q plus 1Q is 1H. What we can do is we can substitute these values here in for our squares. So we can substitute 1C plus 1T in for 1Q twice. If we do that, what do we get? We get 1C plus 1C plus 1T plus 1T equals 1H. Now, you should spot that there's something a bit weird going on here, right? Because if you've got 1C, if you've got this on the one hand, so you've got 1C plus 1C plus 1T equals 1H, and then you've got 1C plus 1C plus 1T plus 1T equals 1H, then what does that mean? Well, it means this should be equal, shouldn't it? 1C plus 1C. The 1C plus 1C here should equal the same as the 1C plus 1C here. But you've only got 1T here, and then you've got 2t here, because you've got 1t plus 1t. What that means is, effectively, that 1t is the same as 2t. All right? Or one lot of t, one triangle, is the same as two triangles. Now you've got to think to yourself, what's the only value that can fit in for t? What could make this true? Now if I put 1 in there, 1 times 1 is 1, and then equals 2 times 1 equals 2. So I'd get 1 equals 2, which is just not true, because it doesn't equal 2. So there must be a number or value that you can put in there where it works. If you want to pause here, I'm going to reveal the answer in a second. Okay, if you're ready for the answer, the only possible value that can fit in for t, or your triangle, is 0. Because 1 times 0 is equal to 0, and 2 times 0 is also equal to 0. That's the only value that can work for your value of the triangle. Join us next time, where we'll be going through another problem. Like and subscribe, and watch some of our other videos.